Good morning and welcome to another exciting UKDEA webinar. We've got around 160 people joining us this morning, so there's still people coming into the room. So please take a virtual seat. Hope you've got a nice tea or coffee and it's not raining where you are. So just by way of introduction, my name is Simon Woodward. I'm the chairman of the UKDEA, so sort of master of ceremonies for this morning's event. We've got a really exciting group of speakers talking about delivering innovations in heat networks. So hopefully you'll find out a lot. Please do engage with the speakers after the event. Their details will be in their presentations. In terms of asking questions, at the bottom of the screen, you'll see two things. One is questions and the other is chat. Chat is for sort of saying hi, good morning. Hopefully it's not snowing. Questions is where please post your questions. I will remind you throughout the event to put any questions there so we can hopefully get a stimulating Q&A event going at the end of the event. So without further ado, I'll just kick off while everybody's joining the room to do a brief introduction of the UKDEA. So we were founded in 2010, 15 years ago. We had our 15th anniversary this summer. We are a heat networks association. We're the largest heat networks association in the UK. We started in quite an unusual way. We were started largely by local authorities who wanted a voice for heat networks. So they created a structure which put full members at the heart of the association, those people facing the pain of investing in heat networks each day, and around the outside are the very important associate members. You can see the full members there at the bottom of the screen in the dotted box, the ones we have today. Essentially, there's not a great difference between a full and associate member. The full just vote on a few things a couple of times a year. All members receive the same benefits that I'm about to go through. So the first benefit is the collective network. We're the largest voice for heat networks in the UK. We'll shortly reach 200 members. We're split roughly 50-50 in terms of membership segregation. So about 50% of the members are system suppliers, manufacturers, or people who advise on heat networks. The other half are people who actually do things in terms of delivering heat networks, running them, operating heat networks, etc. Benefit number two is the journal. So that comes out monthly. That's what's going on in the heat network sector. And also it's an opportunity for you to showcase what you're doing. You can see on the left-hand side there, you've got Polypipe, then Guru, then Vattenfall. 50-60 pages. The last one we sent out earlier on this week was 70. There's an awful lot going on in the sector at the moment. If you want to find out about it, please do join us as a member and you'll get a free copy of the journal. UKDEA website, it's the hub where everything happens in heat networks. We've got our library there, our knowledge base with over 500 documents, plus there's things like the members directory and also many other documents and guides, etc. Benefit number four, once you're a member, you can meet with me as often as you want. We're a free source of what's happening in the sector because we're at the hub of heat networks. If it's happening, I'm likely to know it. And if it's in the public domain, I can share it with you. I also meet regularly with officials from DESNES, often daily, definitely weekly. And as you can see at the bottom there, there's a nice little attestation there from Jodie Peterway from SSC about our ability to act as an advocate for members to government. I recently have taken to describing us as most probably an 80-20, maybe 70-30. So the 80 or the 70 is the business development side. The reason we exist is to develop members' business. That's what we're here for. We're here to advocate, communicate, promote, be the voice for members. The other percentage is the engagement with government, the policy, lobbying for what we need as a sector to make it work. Benefit number five, so this is a benefit that we've flagged up recently. We've been doing it on and off for years. We circulate tenders that are made aware to us, but most importantly, we offer a brokering service. So if you joined, or indeed you're an existing member and you're on this event and you wanted to add to your portfolio that you sell by partnering with another organisation, or even maybe you've got some waste heat you want to sell and you want to reach out to waste heat organisations, then we can broker through the nearly 200 members that we've got to create relationships. Working groups, responses to consultations. We obviously respond to all heat network consultations, plethora of off-gen ones over the summer. We recently responded to the one about the authorisation conditions, the final version. And we also have a number of working groups. We've got a very exciting one going at the moment on Scottish and Welsh issues. We're just setting one up on ambient loops. We've had ones which are still live on counterfactuals. heat network zoning is in abeyance until the government response comes out. Lots going on there. Number 7, webinars. You're here on one today. We run them regularly, at least quarterly, possibly even monthly. We've got another 2 coming up in the new year. The first one is about practical applications of heat pumps, which you can see is in the middle of the screen. We're rerunning that. So in reality, we did that now a number of years ago, but that was very successful. So we're doing that again in the new year. So if you want to find out the latest way to apply heat pumps to heat networks, please do look out for that. And then the one after that will be about how you keep the heat on, as opposed to how you keep the lights on. So it's all about building resilience into heat networks, both in design and operation, and ensuring that when the heat goes down, it's back up as quickly as possible. So we're all hitting that 99.99999% availability. Number 8, in-person events. We have 2 each year. We have Future Build this year in 2026. We will have the Heat Networks Connections Cafe, and a number of members already booked to exhibit in that area. 9,000 visitors across 3 days in early March. If you join, you're welcome to take a slot in the Heat Networks Connection Cafe or indeed in the wider exhibition area. And then we were really excited in summer 2025, because we've grown to such a size, we were able to pull together the UK's first Heat Networks Expo. If you didn't attend, look out for the one in July the 14th, 2026. The Minister is speaking. We're targeting 500 registered delegates. We had close to that in 25, and in terms of people turned up on the day, and 50 exhibitors. So it's a real buzz. It was absolutely packed. Training register. If as a member you offer training, you can put your training in that. It's free to advertise, and either free training or training that you charge for. So if you want to find out any more about the training offered by our members, please do look out for that. It's available from the website. Jobs board. If you remember, we advertise any vacancies for free. So please do look out for those, whether you're a member or not. They're on our website. There's a number of vacancies, typically a dozen or so. Podcasts. If you want to take part as a UKDEA member, or you want to listen to what's happened, we've recorded three now, 2 more in development. I recently did one with Wim Jacobs from Zero Friction. That was really interesting. That talked about turbocharging heat metering and billing systems, but also very interestingly comparing and contrasting the development of heat networks between the UK and Europe. Very enlightening. UKDEA awards. As you'd expect from any association, we run awards, and we will be presenting those in 2026 again, and we'll be adding a few more categories in. So if you want to apply as a member, or you want to join and apply, please do. And then the Heat Network Specifiers Guide, we published this, we launched this at Future Build last year. This is literally a who's who of heat networks. If you want to be in the Specifiers Guide, join as a member and you will be there. And then finally, all of that comes at an incredibly low pricing point, which was set historically because we came out of a local authority membership formation. So it's £1,090 per year to join as associate member, which is what the vast majority of people join us, because there's a limited number of scheme owners developers in the UK, which is a slightly higher price. So essentially it's £1,090, and because we're halfway through the year, to take you to the end of March, it's £545. If you want to find out more, contact myself, contact the secretary. Always happy to have a chat. So Tom, I believe that Richard Hanson-Graville is the next speaker. If you could please drop my slides and put Richard's up on the screen, and we will go forth with Richard. So Richard, if you'd like to join the stage, please, if you're there.
Hi, you're right.
Yeah, good. Thanks very much indeed, Richard. So Richard will talk for the next 15 minutes about the development of a HNTAS quality control systems. Okay, over to you, Richard.
Hi, hello everybody. My name is Richard Hanson-Graville. I'm the Technical Director at Heatweb Solutions. Right, I'm just here really to give you a bit of a brief run through on some of the recent developments in relation to quality control and HNTAS. Okay, so as I'm sure most people will now know, we've recently had the TS1 technical standard released for HNTAS. which puts us in a new position that we now have some revised technical guidance that covers pretty much everything to do with heat networks and the installation of HIUs, the design of systems. A very comprehensive document, as well as KPIs and targets that we all need to achieve now as an industry. There's a great deal of work gone into technical standard TS1, and while most of us are still reading through it, it is a very comprehensive document. A lot of effort's gone into a lot of work from across the industry, and this will form the foundation of our quality control systems really going forwards. The key now is to align the works in the field, so the actual designs and the operations on site with the technical standard. It's about disseminating the information and getting it through to the engineers on sites who make the decision to actually impact on quality. Okay, so the technical standard itself really comes down to the two sections. All the design information tells you how you should be building heat networks, all the finer points of system design, as well as some nice things have been consolidated, some new terminology has been brought in, and a lot of the confusion has been cleared up, and a lot of standards have been unified. So we have the technical standard side of it all pinned down to follow. And one of the main bits about it also is we have KPIs. So sorry, I think slides have gone out of order. KPIs. So as well as defining how to achieve things and how to do stuff, the technical standard provides us with a set of KPIs for different elements of heat networks. So this is through from the energy centers, through substations, distribution networks, and consumer connections, or HIUs. So you have some very specific points with almost all of the data drawn from metering infrastructure, but also with a deal of it pulled from other infrastructures such as BMS systems, where you might have things like differential pressures and certain temperatures and certain bulk meters that you need to read. So the bit really I was here to just chat very briefly about was the operational KPI side of it, which was how we are working with engineers to effectively put these KPIs into their hands, so that they can achieve them. Right, I'll jump back a bit. Okay, so to assist in this, we've been developing some various tools, material to assist in these various quality control procedures. We've put this all on a GitHub site where it's open source, which is called HNQAP, which we can provide access to. So this is really materials which are useful for engineers and various bodies in actual physically doing the works on site to meet the various HNTAS KPIs. On the site, we've included the protocols and things for pulling data from BMS systems, which is one of the sources of data that you require for KPIs. So this is using the open protocol that we've developed, which pulls data from substations, various metering infrastructure. So this would be how we will be pulling data through from BMS systems through their standard protocols to obtain data points for filling in KPIs automatically. The other really bit here, which is the main bit for today, was just to the real part of the puzzle is acceptance testing. So this is what the engineers do on site as their actual quality control procedures. So one of the main bits of tools that we're developing to back up HNTAS is a acceptance testing app that can be used by engineers on site to perform various commissioning processes and acceptance testing processes, with the idea that this aligns with the various HNTAS technical standard points to make sure that they're met. So this is a kind of tool that sits on any app's phone or tablet, and is like a logic-based questionnaire, so that depending on the type of HIU that you select, you'll be guided through the various different questions. This is a tool that's been developed in partnership with various manufacturers so that it can grow into, so it's not just a generic tool, it can go into some quite fine detail. I can partner with other people in the industry to deliver an open tool that can be edited and can be adapted to the various sites. That's one of the things about the standards. There's a standard set way of doing things, but every site has its own unique aspects that need customizing. And we find that an electronic quality control system can adapt to these nuances in all the technical standards quite well, without overwhelming engineers. The main idea is to have clients able to track the progress of engineers on site against the various TS1 technical points, with the idea of reaching pass and fail points on your KPIs. So really, I just wanted to make everyone aware that we're working on software of this nature to help overcome the hurdles of getting engineers to the point where they can actually start running with the new technical standards. Okay, that was all really. It was a pretty brief talk today. Thank you for listening, and happy to field any questions.
Okay, that's great. Thanks very much indeed, Richard. Much appreciated. I'll ask you to leave the stage for now, but we're planning a Q&A session at the end. There's another 4 speakers, so if you don't mind hanging around in the green room and coming back at the end. I see Steve Pete's already asked a question in the chat. You're welcome to respond to that with typing an answer, or wait until the end for the Q&A. But for now, thanks very much indeed, Richard.
Cheers, everyone.
Take care. Cheers. Okay, Tom, thanks very much. So now I'll invite Steve Wilkinson and Terry Mahoney, respectively the Chief and Revenue Growth Officer and Key Account Director for Evinox, to join the stage, and they will be talking about utilising Smart Talk to deliver performance improvements. So over to yourself, Steve.
Thank you very much, Simon. Good morning, everyone. My name is Steve Wilkinson, and I'm the Chief Revenue Officer for Evinox. I'm pleased to present this case study to you with my colleague, our Key Accounts Director, Terry Mahoney.
Good morning, everyone.
Our case study, excuse me, sorry. I'm pleased to present the case study to you with my colleague and Key Accounts Director, Terry. Our case study will demonstrate how Evinox heat network can be optimized to adopt low carbon technology, utilizing our Smart Talk software platform at the Riverlight Heat Network. Our mission at Evinox is to empower heat network operators by delivering turnkey smart heating solutions that reduce cost, ensure compliance, and maximize reliability. You may be familiar with Evinox from our supply of heat interface units. However, we also supply a range of solutions that improve the efficiency and reliance of heat networks. Heat network operators face a range of common challenges that include, but aren't limited to, ensuring reliance and affordability of heat in transitioning to low carbon technologies. Common performance issues on older heat networks include high return temperatures and high flow rates. This results in unstable delta T conditions and poor efficiency that impacts the performance and reliability of heat networks. To tackle this issue, we deliver our 3-stage retrofit methodology. During our discovery stage, we diagnose and analyse heat networks using our Smart Talk platform. We develop a tailor upgrade and design strategy for the heat network, and we deliver our optimization solutions and then continuous intelligence monitoring and metering to ensure the long-term performance of the heat network. The challenge facing the Riverlight Heat Network will be familiar to many heat network operators, that being how to upgrade systems that include older HIUs. To tackle this, we utilised our Smart Talk platform. Smart Talk can analyse in excess of 400 parameters and variables that are visible remotely, providing a forensic analysis tool of heat network performance. Smart Talk's extensive range of parameters optimise both comfort and efficiency. It can be used to compare aggregated HIU data and bulk meter data. Smart Talk can aggregate HIU data to distinguish between return temperatures where they are not segregated by the bulk meter. It can readily pinpoint adversely performing individual HIUs, and it can display graphically aggregated HIU return temperatures, both historically and in real time. So I'd like to hand over to Terry now, just to take you through all the improvements that we delivered on the Riverlight heat network.
Yeah, thank you, Steve. Good morning, everyone. I hope people aren't keeping too much an eye on the cricket, because I think Ben Stokes has just been run out, which is a bit disappointing. Anyway, what Steve has touched on there is how we're using our Smart Talk, our user interface capability, which connects to HIUs via a network and cloud, so that we can get an insight into the performance of the heat network based on the data that we're getting from HIUs. And what we found here is that in addition to doing practical upgrade work on older HIUs to bring their performance up to a contemporary standard, in addition to that, what we also need to do is to understand and refine the parameters that are controlling the HIU. And because we've got visibility in relation to those parameters, we can see them, we can change them remotely and globally. And then because we can see variable data as well, we can understand what kind of impact those changes have on the overall performance of the heat network. And when we talk about performance, we're looking at reducing return temperatures and flow rates without detriment to the comfort of residents in relation to heating and hot water. So when we've done this exercise, we've done it in conjunction with the customer service team, so that they basically are on standby to pick up on any adverse reports back from residents if they feel that their heating or hot water is suffering in any way as a result of the work we're doing to refine the performance of HIUs with regard to trying to improve the heat network efficiency, so reducing the return temperatures and flow rates. So once we know that we're not upsetting the residents, we can then look at the kind of results that we get by aggregating the data that we're getting from the HIUs, and we can see how the overall return temperature of the heat network based on the aggregated data is benefiting from the variation of the parameters that we can change. That's one way we use the data that's presented to us via our Smart Talk cloud solution. Another way is aggregating data on specific networks where you've got bulk meters on that network also recording return temperature data. And this was a useful exercise, because what we were doing here is aggregating the data from the HIUs and saying, well, the return temperature of the water on this leg of the heat network should be this based on that data. And that's what you can see in the yellow column there. But in the middle column, the one with the white background, you've got the actual recorded return temperature from the bulk meter. And in this example, on these particular blocks on the development, there was a big difference. So that really pinpointed there's something adverse affecting the return temperature of the network external to the HIU, but we've rationalized that based on data from the HIUs. And then when we further investigated this particular riser, we've discovered that there was a bypass open at the top. And so closing that then brought the actual temperature, return temperature, down to where it should be. Another aspect is where we want to distinguish aggregate, we want to distinguish return temperatures from different aspects of the heat network where they're not segregated by bulk meter. So we can't differentiate using bulk meter return temperatures. So here's an example where it was useful to know the return temperature from residential HIUs and differentiate that from return temperature from the HIUs occupying commercial spaces. Now, the commercial spaces were established in each and every one of the networks, and so each commercial space was contributing to the return temperature as recorded by the HIU, well, by the bulk meter, sorry. But by aggregating the return temperatures based on HIU data, we could then separate that from the residential HIUs from the commercial spaces. So then we could see whether the commercial HIUs were performing better or differently to the residential and vice versa. And in this example, there were different responsibilities for the commercial units than the residential. So where actions needed to be taken, we were able then to communicate to the right people what should happen next in the interest of improving the efficiency of the overall heat network. As well as looking in overall terms, we can also drill down into and pick up the performance of specific HIUs. And we do that basically by collecting that data and then sorting it and ranking it to help us pinpoint which specific HIUs might be performing adversely. So in this example, we've ranked it in descending order of flow rate. Flow rate through an HIU is a good indicator of whether an HIU is performing in the way it should or whether it isn't. And delta T, the primary flow rate, the difference between the primary flow rate and return temperature through the HIU from the heat network is another indicator. So in this example, we're highlighting excess flow rate, and that then implies that low delta T. So we can see specifically which apartments need attending to. And as you can see, the pub is performing very well. I think the pub is getting a lot of attention anyway, and so is always going to be in good shape. But you can, in the midst of effectively performing HIUs, you can use the data to pinpoint adversely performing ones, and then so we can direct our efforts to getting access to those specific apartments and taking appropriate action. And in addition to all of that, we can take that data and through Smart Talk, we can aggregate it graphically. So we can see, based on aggregated HIU data, overall return temperatures over a period of time. So if an event has happened which has adversely affected the performance of the HIU, i.e. the return temperature has suddenly gone up, we can track back to the point in time when we think that happened, and then we can take appropriate action. And this is where we can be comparing data from HIUs historically with data from bulk meters, for example, to understand where those two pieces of information diverge. What was the point where something adverse happened? And then that helps better inform what the issue was and get to the bottom of it and solve it. Or in this case, what we're looking at here is taking positive action to reduce the overall return temperature based on HIU data, which we can see in real time. And this is confirming that the action that we were taking at that point in time has indeed contributed positively to the performance of the heat network by reducing the overall return temperature. So if you're looking at that, Steve mentioned the Riverlight project over a period of 12 months or so with practical apartment HIU upgrades and the refinements using the Smart Talk interface that I've touched on. We've been able to reduce overall return temperatures from 53 degrees to 40, and also reducing the flow rate through the heat network by 60%, from approximately 25,000 litres an hour to about 10,000 litres an hour. And then this is also helpful when we get to compare the benefit of all of this in terms of the impact of the HI unit's performance on the overall heat network, where we can make a comparison. And this is an interesting one, where in one block in a development we've got mechanical HIUs, and then in another block we've got Evinox HIUs, and we've carried out this work of ongoing refinement, and you can see the difference that will bring to the performance of the network in terms of reducing the overall return temperatures based on the kind of capabilities I've just been touching on. So that's an insight into some of the detailed way we go about contributing to heat network performance. So back to you then, Steve.
Thanks, Terry. So, what was the impact of the work that we delivered at the Reheat heat network? So, the impact demonstrates that existing agent systems can achieve compliance and be ready for decarbonisation without major plant replacement. Reheat's 14-year-old HIUs are transformed through the use of smart talk diagnostics in targeted component upgrades. That led to a project that had a very attractive investment payback with a return on investment of 3.8 years. It dramatically reduced excessive flow. It had significant improvements on the delta T, and it had significant annual cost savings of around about £90,000 per year on historic performance. It reduced the return temperatures dramatically, and it allowed for the adoption and the operation of heat pumps within the development. So we'd like to thank everybody for their time this morning, and we'll hand you back to Simon and the team.
Thanks very much indeed, Terry. Thanks very much indeed, Steve. That was a really informative presentation. Please stay in the green room for Q&A at the end. There's already a question in the questions box. So Tom, if you don't mind putting Evinox's slides down, we'll now invite Peter Horne. Peter Horne is the principal engineer from Fairheat to come and talk about retrofit and performance improvement results as a result of Richmond Park Avenue project. So over to you, Peter. Do you just want to kick off, make sure I can hear you okay?
Hello, you hear me? All
Perfect.
good.
No worries. Thanks very much.
Okay. Hi, guys. As Simon said, I'm Peter Horne. I'm a principal engineer at Fairheat, and I work in the optimization department, which specifically looks at taking poorly performing heat networks from a state of poor performance all the way through to a better state of performance. On this particular project, which is Richmond Park Avenue, it's located just outside of Sheffield, and it's actually 9 boiler houses connected to 299 flats and a community centre, and that is all very high density flats and houses, townhouses. Historically, it's quite an old development, and the previous system was running at 80 degrees, or the boilers were operating at 80 degrees with the heat being distributed at about 75 degrees, and there was lots of reliability issues. You can actually see on the diagram on the right hand side that boiler house 5, right at the bottom of the development, has been chalked off, and that's because the energy centre actually, or the boilers failed, and the energy centre was no more, and so they decided to connect it to boiler house 6. So yeah, the sort of general status was disrepair, really, when we got to it. Very high heat losses, and I suppose one of the things that Great Places, who own this development, really wanted to achieve through the retrofit project was to modernise the system. Previously, before we did the retrofit works, there was a very, I suppose, archaic billing system introduced, a very manual process and labour-intensive process. And one of the things that they wanted to do was make sure that that was as slick as possible to ensure that residents were getting a fair deal, but also that process was as quick and as streamlined as possible. On top of that, there was obviously need for improved reliability and efficiency as well. So this was, because there was 9 boiler houses, this was quite a complex route to project delivery. We actually used the HNS fund to do an optimization study, so an in-depth assessment on one of the 9 networks. That was done on network 3. And then we went through what we called an applicability phase. So taking the findings from the optimization study, that was a detailed assessment of one, and assessing the recommended actions, their applicability to each of the other 8 networks, and identified where there were variances and produced a recommendation for those variances, and then where there were similarities, identify whether that recommendation or that action was going to be similar cost, higher cost compared to boiler house 3, or lower cost compared to boiler house 3, in order to develop a project plan for the whole development. In tandem to that, we also did like a decarbonisation options appraisal for the long-term decarbonisation plan. That's the sort of next phase. We then applied for HNS capital works just on the performance improvement opportunities. So looking at what we could do within the flats, what we could do in terms of heat losses across the network, and then how do we make the existing boiler houses more energy efficient. We were successful in getting that funding, and then we started the design in December 2023. We started on site in May 2024, and we finished the project about this time last year. So just in terms of scope, I suppose the key things that we did was, within the dwellings previously, there was cylinders within each flat, and also radiators were largely uncontrolled, both from a flow rate perspective through them, and also the fact that residents couldn't really control their heating. Thermostats and programmers had failed. TRVs weren't isolating the radiators. I imagine fairly consistent problems that people see across the industry when it comes to aging heat networks. So we put a plan in place for HIUs to be retrofitted and replacing those cylinders, changing the DHW, the hot water supply, from stored hot water to instantaneous, therefore reducing fairly dangerous temperatures, sort of 65, 70 degree hot water outlets down to 50, 55. And then on the radiator side of things, introduce some controls, both from a flow rate control through each radiator and also from a programmer and thermostat perspective, to give the resident an ability to use heating and hot water when they wanted to, and not be dictated to by the system. Within the energy centre, we introduced some weather compensation for summer winter operation, and then also across both the energy centre and the network, removed bypasses and introduced some upgraded insulation to new build standards. Now, what that's done is provided a safer environment for those residents, has allowed better control of their consumption, and also improved their heating tariffs, which is huge, considering that the majority of the residents were sort of in the vulnerable customer category. I think a sort of separate nice little bonus for residents is because the cylinders are being removed, they get additional storage space. Quite high density living and small flat storage is always I suppose an issue, even on new build developments as well. But yeah, what you can see from the billing side of things is on the right hand side a graph, pre-retrofit, post-retrofit of the annual bills. The average annual bills have halved, over halved, and then the VWATs that we achieved across the development were excellent, and the improvements were also excellent as well. So whilst the technical side of things is great, and we're very, very happy with the results, one of the key benefits and one of the key findings that we had, and the thing that we're most proud of with this project is we were able to deliver the retrofit like on time and within budget. We actually gave some HNS funding back for this project. So whilst achieving the technical standards, we were able to introduce a process that allowed that retrofit to take place very effectively. And the reason for that is largely to do with the work that we did up front. So whilst we did engage stakeholders very, very early on, even before that, we introduced strategies to identify the people on the development who were least likely to respond to our engagement. So we actually started using vulnerable customers registers and debt registers to identify those who are likely to be either vulnerable from a disability perspective or financially vulnerable. And we made sure that we engaged with them very, very heavily and introduced that engagement through various different teams. So we made sure that the maintenance team were aware of what we were doing, and gave them some training to make sure that they were fully aware of the project's intentions. And then also, obviously, between the heat networks team, the housing team, the gas team, all very much aligned with our communication, so that if any complaints came through during the mobilization phase of the project, we were able to move them into a project upgrade very, very quickly. Increasing confidence and understanding as well really, really drove engagement, and that collaborative approach right from the very off was very successful in booking those appointments in. This is the many ways of which we were able to communicate with residents, providing resident guides. We had a site office in a void flat, and we were able to provide leaflets, emails, phone calls, engagement days, postcards, you name it, we kind of did it. And what that meant was that we had demand, so residents asking for us for a booking to exceed our ability to supply, which was actually quite surprising, and we encouraged our contractor Broadoak to get as many people on site, get as many retrofit sort of pods on site to make sure that we were able to keep up with that demand. What you can see is we pretty much did all 300 retrofits within the space of about 4 months, which was very, very good, and you know, testament to the work that we put in right from the start of the mobilization phase. So I suppose the key takeaways, you know, when we put this slide together earlier this year, that early engagement was really, really important, and one of the messages that we wanted to get out there. We normally go by the rule of the 80-20 rule, so 80% of people will take you know, no time at all, and then 20% of people will extend the retrofit project duration. But that early engagement and the processes that we introduced through this project moved that to a 95.5% kind of distribution. But there's another key takeaway in here is obviously with consumer protection regulations coming in 2026, most organizations are going to have to get those vulnerable customers registers in place and have access to them, and then also their debt management procedures closer to the Heat Networks team. So I'm quite optimistic with future regulations. If we can tie those consumer protection elements into retrofit projects, we should be able to start impacting project durations, which would be really, really good for confidence in the retrofit sector. And this is the final slide. Yeah, the next step for Richmond Park is to try and decarbonise and utilise that decarbonisation options appraisal to connect a few of those networks together and start looking at heat generation options other than the gas boilers that they've got currently. So that's me done. Thanks very much, and I'll stick around for some questions at the end.
Hey, no worries at all. Thanks very much indeed, Peter. What a really interesting presentation. Thanks very much.
Thank you.
Okay, if I could now invite Oisín from Reheat to come to the stage. Oisín's a senior consultant and will be presenting learnings from innovation in community heat. So over to yourself, Oisín.
Thank you very much, Simon. I'm sure you can hear me.
Yep, perfectly.
Perfect. Thank you. Okay. Morning, everyone. Thanks very much for joining and listening to us this morning. So, like Simon said, my name's Oisín. I'm a consultant with Reheat, and I'll present some of the learnings from a Scottish Government programme that we delivered over the past 2.5 years. So a bit of background to who Reheat are, in case you're not aware. We're a low-carbon heating consultancy, primarily based in Northumberland. That's where our office is, but we work across the length and breadth of England, Scotland and Wales. Our specialism is in renewable heat, particularly community energy, district heating and biomass and forestry supply chains. We also deliver training and advice where required, so we're on some government panels for delivering that as well. So kind of both an installation and a consultancy team, so we've got a range of expertise. So the programme that we delivered for Scottish Government was to support communities in decarbonising collaboratively. So this was a pilot programme aimed at learnings to understand what were the barriers and opportunities for communities to decarbonise. It was administered by Local Energy Scotland, and then Reheat were the technical consultants on the programme. To our knowledge, it's the largest integrated programme of heat decarbonisation studies in the UK to date, with a value of £260,000. So it was quite a large programme of works. And it looked at a whole range of technologies and a whole range of purchasing types. So we could do collective purchase, communal heat, so our heat networks. I'll focus today on some of the heat network projects that we looked at during the programme. We could include non-domestic properties on it as well as simply domestic. So there was a couple of industries on the programme. Primarily, the project had to be community-led. So the idea had to come from the community itself, but it did not need to end in a community-owned project because that can be too complicated sometimes for some of the groups to undertake themselves. Up to 3 stages of support were available. So generally, an initial review to make sure the idea is worth investigating, and then they'd get 10 days of consultancy support from Reheat to deliver a high-level feasibility study. Retrofit focus, so no new builds included on the programme, and then looked at a whole variety of heat sources. That's just a whistle-stop tour of the programme. So along the way, I'm not going to go through this whole list of people who we worked with during the 2.5 years, but it's just to say that we did not work in a silo. We engaged with as many relevant stakeholders and partners as possible to extract as many learnings from them as possible and to get the widest breadth of knowledge included in the reports, with the main aim of just giving the communities the best quality report possible. A mixture of charities, local authorities, third sector organisations, industry, and government associations. So what we then did during the programme was deliver 32 projects across Scotland. So across the length and breadth of Scotland, diverse in range, type and size, from 6 properties on a farmsteading up to whole towns. And as you can see from the map, they were the whole length of Scotland. So right up in Thurso, island projects, inner city, Dundee, Glasgow and Edinburgh projects as well. So really diverse, and diverse in technology type as well. We looked at all possible heat decarbonisation solutions for these communities. They could come with their own suggestion if they wanted to look at something, or Reheat would make a technical suggestion to them if they just wanted to decarbonise heat and weren't particularly concerned about what the heat source was. So what I'll do is go through 2 of the case studies from the programme to highlight some of the challenges and learnings that communities in Scotland particularly, but the learnings are similar for the rest of the UK, that they will have if they wanted to decarbonise collaboratively through a communal or a heat network type system. So the first one is the Thurso project. So Wormley is the name of the project. It's based in the Ormley area of Thurso, which is an area of high deprivation. Community group are operational there, supporting a lot of people in fuel poverty, a lot of people with drug and alcohol awareness problems, and they also wanted to then alleviate fuel poverty by looking at decarbonised heat solution. There's 3 large heat users in the area: NHS Dunbar, which is the local hospital, the local high school, and the UHI campus as well. And they all have a biomass heat system in them currently. So the community group wanted to investigate, could this be expanded to look at a district-wide heat network, including about 1,000 properties on that network. So essentially using them 3 as a base load to then develop from there. The high level of these properties were on direct electric, which is clearly a challenge if you're trying to connect them to a heat network, because they don't currently have a wet heating system in place. And in the eyes of Scottish Government, those on direct electric are already decarbonised, because the grid will reach net zero by, I think in Scotland it's 2030, 2035 maybe. So when you're looking at funding, these people who currently pay the highest price for their heating will not be eligible for funding in terms of decarbonising. So it's a challenge. And then the teleswitch services was switched off, I believe. So that's when they could get a cheaper overnight rate. So now people who are already in fuel poverty are probably going to be pushed even further into that. So finding an alternative solution is really critically important. What we did was gave them 10 days feasibility support looking at this biomass district heating solution that they wanted to. We also looked at alternative options like ground source ambient loops and individual air source heat pumps as a counterfactual. Because of where they are, they have access to a lot of wind curtailed electricity, being in the North Highlands of Scotland. So a lot of wind farms there could potentially sell them cheap electricity on an overnight rate for approximately 4 pence per kilowatt hour. We tried to engage with some of the brokers for this, but they would not engage with us with the time limits that we had. So we couldn't really investigate it, but it's certainly an opportunity that they might look into further. We looked at essentially two options for the biomass district heating scheme, whether the large industrial heat users connected or not, and that obviously makes a massive difference to the viability of a system and the costs associated with it. Like I mentioned, about 50% of the properties don't have a wet heating system in place, so that's a major barrier for the uptake of a heat network, because they'll have to undergo significant retrofit then to install pipes. But there is a large proportion of houses in the area owned by the local authority or by housing associations. So that gives, if you could get the local authority or the housing associations to buy in a good base load for connecting to the network. Ideally, you want 60%, I think it's a subsidy number for people to connect. But if you could get all the housing association and local authority, and then some of the owner or private rented properties to connect as well, we'd probably be close to that number. Because Wormley then joined the program quite early on, they were then given the option of continuing their journey through the community heat development program. And this was in the stage 3 report, which was like bespoke additional support for them, where essentially they got to say, what part of the project would you like to investigate more? What they wanted was to look at the capital cost of the network, because within 10 days we couldn't really develop like an accurate cost for that. And then some outline designs of what an energy center would look like. And we also were able to do some air quality modeling for them, because with a biomass district heating scheme, there's a lot of negative connotations in terms of what impact that will have on local air quality. The image there just shows the kind of outline schematic that our engineers were able to produce for them and what their energy center would look like. We're able to put it into a location. We're able to talk to the local planning department about this and how agreeable or not they would be to it. The Highland Council have used Wormley as a case study in their LHES document, so it shows that they are supportive of the program, which is really good. You might not be able to read the bottom right hand corner, but that is the results of the air quality modelling that was carried out, and it shows that there's no negative impact from the biomass installation on local air quality in Thurso. It's actually likely that there will be an air quality improvement from the installation, because you'll be able to take out those single point source heat use sources of heat, like oil and LPG boilers, because there's no gas network up there. So likely that air quality will actually improve. And then some of the other things we're able to give them are preliminary ownership advice and a whole range of other pieces of information, like fuel supply chain analysis and the impact, a comparison of the impact of them large users not connecting, so the hospital, the school, and the high school. Clearly, the return on investment for a project of this scale with this level of heat demand is quite low, especially when you consider that it's between like £11.5 million or £10.5 million that would have to be invested. So it's going to be very difficult to get the project off the ground without some new investment techniques or new investment strategies being put forward, either through social development funds or Scottish government to stump up a lot of the money. But clearly massive opportunities here for heat network development. So what the program then, unfortunately, we could only deliver so much for them, and the program ended at the end of March. So they have all this information now, and they're trying to actively progress with this, but without funding, it's difficult. So what their next steps are is to understand what ownership structure they want the project to be. So that they want it to be wholly community owned, or are they happy for someone else to own, build, operate the system, and that they just purchase heat from them? And that really is a community decision. We provide them with advice and laid out the options, but it's for them to decide. They need to do like a much more detailed techno-economic assessment than we were able to do within the time, and more accurate heat demand data as well, because a lot of it, what we were able to do was based off EPC data, which I'm sure everyone knows is less than accurate sometimes. Specific learnings from this project is what I mentioned there, with the large percentage of users in fuel poverty are already decarbonized. So how can there be a just transition if those who are paying the most are going to continue paying the most for their heat? It's something that's been highlighted to Scottish Government many times. The return on investment isn't attractive, but addressing fuel poverty and decarbonisation is something that Scottish Government have targets for, so they will hopefully come the new year, when the new government is in place, put something in place for that. Like the local authority is very supportive with it. It fits within the Caithness and Sutherland Development Plan, and it was used as a example in the Highland Council Local Heat and Energy Efficiency Strategy. So it's really good that the council are supportive and have bought in, but I don't think they're in a position to pay for everything at the minute. But if they could be a project partner in future, that would be very good. And yeah, like all community energy projects, funding is a challenge. So that's a whistle-stop tour of Wormley, and then I will go through one more case study as well, and that is Deanston. So Deanston is a small village on the River Teith, which is just outside Stirling, so central belt of Scotland. Deanston hosted a community engagement session, and the idea of district heating came from that, where the community had heard about district heating, didn't understand it too much, and wanted to investigate the opportunity and would it be viable for them, primarily because there's Deanston Distillery, which produces a lot of waste heat that is not used at the minute, and they've seen it as an opportunity to capture that waste heat and develop a local heat network from that. So it's only 240 properties, so quite low heat demand in the village itself, and there's also essentially no non-domestic heat use. There's a very small school, a supported living facility that we didn't get great buy-in from, and a shop that is closed, I think. So really it's just the domestic properties here. They currently have a wide range of heat sources, all fossil fuels or some direct electric in the conservation area. But yeah, the primary idea for this project was to capture waste heat from the local distillery to create a district heating scheme. There is alternative sources of waste heat available, such as like a simple water source heat pump from the river, or from the wastewater treatment plant that also exists. They received similar stage 2 support, so another 10 days where we looked at their idea in detail and did some comparisons to what alternative options might be. We had some very positive engagement with the distillery. They were happy to let us into the facility, talk to us around their heat profile, when they are on, when they're off, because they shut down over Christmas, which obviously will have a massive impact on heat network viability, because probably got the highest demand then. So what is the alternative for when the distillery shut down? What's the alternative heat source for the network? Could we just have a buffer tank big enough? Would there be enough capacity to supply heat to 240 properties during that time? These are just kind of like the basic questions that need answering at the very early stages of the project. Part of the village is a conservation area, which obviously adds a challenge, because you can't have any like visual changes to that part of the village, but most of the work would be underground and like design installing pipe work, which you wouldn't see any difference to what the gas grid does there, just bringing heat into the homes. So it would be fairly similar. And again, there is a high proportion of housing association and local authority owned homes in the village. So to get buy-in from them is critical. There wasn't as much buy-in from the local authority in Deanston, so it's Stirling Council. We did engage with them. They weren't as keen as Highland Council. They again got to do stage 3 of the program, so we got to do a bit more bespoke analysis for them as well. This looked at alternative heat sources, such as capturing heat from the river, Theoretically, there's 93 gigawatt hours of heat available, but in practical terms, what would that mean? That would require a site survey and like monitoring equipment in the river over an extended period of time to be able to identify this. The wastewater treatment plant also has some, but the low level of heat in Deanston, because it's such a small village, means that making the economics of it stack up is difficult. So you can see there the IRRs are incredibly low. So really, the distillery is crucial to getting this project off the ground. Then next steps for them is similar. They need to engage further with the distillery to understand, are they actually going to buy into the project? Because it's all well and good, the manager on the day saying that they are supportive, but they will need like contracts in place, which is a bit more difficult to do, especially when it seems like the whiskey industry has taken a bit of a nosedive with tariffs being introduced. And if not, then they need to look at them alternative sources of waste heat, if that's still the avenue they want to go down. Learnings from this one is that wastewater treatment works offer a significant resource to communities. There's wastewater treatment works in essentially every town and village across the UK, and it is a really good resource of waste heat that should be available for community groups to access. But it's just about accessing that data. So we spoke with Scottish Water Horizons, who are the ones who manage them assets in Scotland, about providing that data, like recording it and making it available to community groups if they want to be able to do something similar and look at the feasibility of extracting heat from them. The project looks very different with or without that distillery buy-in, so it's important to clarify that at an early stage as possible. Also, the waste heat from the distillery is obviously depending on them not carrying out any changes. Currently, they have a SEPA license to export that waste heat into the River Teat once it's been diluted to an acceptable level. If they were to ever capture that heat and reuse it themselves, that obviously changes the scenario completely. So important to understand what might happen there. And power is obviously important to complement this project. This would be heat being upgraded with a heat pump more than likely, but the cost of electricity currently is prohibitive for that. So unless they can access that electricity at a cheaper than commercial rate, it is not looking like a viable program of works at the minute. So alternatively, could they look at individual air source heat pumps collectively purchased? That is for them to decide. So I've gone through two projects there really quickly, and there's so much detail in each one. But there will be a final report that summarizes all this. It is currently sitting with Scottish Government, as it has been for about 6 months, which is very frustrating because we did a lot of work on this that we want people to share with people and talk about and get people's opinions. But there is a whole other load of resources as well that was developed as part of this that are either available through Reheat or through Local Energy Scotland. And if any of them that are on the screen there are of interest, contact me. I'm happy to share as many as I can, and hopefully, like any day now, that the final report will be available and we'll be able to go through that with everyone as well. So final slide then, just with the primary learnings are: we have to decarbonize heat. It is not an option. These communities are trying to find ideas to do it themselves, and if they can't, what is the alternative? There is Scottish government targets to decarbonise everything by 2045. It's a matter of funding, essentially. So something needs to change. Significant capex challenges to overcome. That kind of goes hand in hand with that. The running costs of shared systems, are they affordable once the overheads are added? So cost of fuel is one thing, but then billing and maintenance and insurances are stacked on top of it. So it becomes a question then whether it's viable or should everyone just do their own thing. Are responsibilities relating to heat networks manageable for community groups? I don't have an answer for that. They are challenging, but with the right training, I'm sure everyone could do it, but not everyone's as capable or as willing to learn maybe. Evolving technologies and tariffs, of course, across the program, new technologies, new tariffs, octopus ones came out. So everything's always updating. So feasibility reports that were done at the start are not as accurate as they could be now, because something new will have come out. So it's interesting to try and keep up to date with that. Addressing repair and maintenance is key, but there's no point installing a decarbonized heat solution in a building if the facade is crumbling. Critical role for third parties, community engagement, like is so important. You can't install collective or collaborative solutions unless everyone's on board. And then it's the same. Did you build an existing support, or do we need new approaches? More than likely, new approaches are needed. But yeah, that's the presentation. Sorry, it's a bit whistle stop and trying to get across a lot in one 15-minute presentation. But thanks for listening.
No problem at all, Oisín. Thanks very much indeed. Really interesting presentation. So if you could stay around for the Q&A session. Tom, if you could pull the slides down and put Peter's up, please. Thanks very much indeed. Much appreciated, Oisín. So the final speaker today is Peter. Peter's from IWTM, and we'll be talking about 1.8 million litres protected by chemical-free innovation. So let's finish on that innovation. Peter, over to you.
Thank you, Simon. Thank you, Oisín. Very interesting case studies there you've got. Hopefully this is another one. I am Peter Linehan from IWTM. I'm a technical sales manager, and just to give you a brief intro into IWTM, it stands for International Water Treatment Maritime. So we have been protecting the marine industry from corrosion for the last 30 years, but only in the last 6 years have we been protecting the building industry in the UK market. And today we're going to be talking about a very large district heating system protected by chemical-free water treatment. Some of you may know it as LUNZIP. So Lancaster Uni Net Zero project. And it's an existing district heating system which is supplying heat to around 65% of the university campus, and they want to, which is about 14 kilometers of underground pipework, and they want to expand that so it produces or provides heat to 95% of the campus, which means an additional 6.5 kilometers of pipework. So that requires a new net zero energy center. Within that energy center, you have 4 air source heat pumps. You have 7 water source heat pumps producing 8 megawatts of low carbon heat. And with any type of heat pump, you're going to need a lot of storage. And they have 8 180,000 litre thermal stores, which in itself amounts to 1.44 million litres of water. So with this particular district heating system, we're talking huge, vast amounts of water that needs to be treated and prevented from causing corrosion. They did receive grants, just to touch on it, from the Green Heat Network Fund and the Heat Network Efficiency Scheme. So whenever you have a heat network, no matter how large it is or how small, you're going to have 2 choices. You're going to choose whether to go down the traditional chemical dosing route or the innovative chemical-free route. With this size system, you're going to have a huge environmental footprint that you have to consider. Just to initially fill the system to prevent corrosion, if you're going to use chemicals, you're going to use approximately 10 tons of chemicals. And you're going to be left over with 408 25-litre plastic barrels that you have to dispose of. With chemical free, you're going to need to fill with demin water, and in comparison, that is only 2.4 tons of resin, which can be disposed of and energy created by sending it to energy from waste plant. That's not to mention the ongoing environmental impact of continuously dosing for the life of the project, which could be 40 years, And that is in comparison, you've got 5 tons of chemicals over 40 years compared to 1.9 tons of resin just to treat the water going in. So straight away you can have a saving and have an environmental impact on the choices you make. And if you didn't know what chemical-free water treatment is, it maintains and protects closed-loop heating or cooling systems from corrosion damage without the use of chemical inhibitors or biocides to kill bacteria or any cleaning agents. And we do this by controlling the causal elements of corrosion rather than continually addressing the symptoms. And we used a German standard for water treatment called VDI 2035, which was released back in 2009, where if you were to meet the strict set of water parameters, you've engineered the water to be in a non-corrosive state. And some of the key parameters are dissolved oxygen, which is the #1 cause of corrosion, pH, and conductivity. So to engineer the water to a non-corrosive state, we need to get the dissolved oxygen below 0.1 milligrams per litre. And thinking about your drinking water that you're having right now, it's about that has about 9 or 11 milligrams per litre of oxygen in. So we are reducing that dramatically down to below 0.1. And remember, that's the #1 cause of corrosion. So if you control your dissolved oxygen, you're effectively controlling your corrosion rate. You want your pH of the water to be between 8.2 and 10. And you want that because majority of bacteria can't survive within that pH level. And pH between 8.2 and is majority a good pH for most metals. So holistically, VDI has thought about what is good for the majority of the system. And conductivity. Corrosion is an electrochemical process. So you want to get your electrical conductivity of your water to be as low as possible. You want it below 100 microsiemens. And effectively, if you get it below that level, it means the dissolved oxygen ions in the water cannot travel around as fast as if it were as a higher level. So to get it down as low as possible means the dissolved oxygen ions cannot travel very fast around the system, effectively lowering and slowing your corrosion rate. I would highly recommend having a look at the CSA's, Commissioning Specialist Association's Technical Memorandum TM20, which is the first UK guide on chemical-free water treatment for closed-loop heating and cooling systems. So this will give you a good basis on what chemical-free water treatment is, how to pre-commission your system, how to clean up an existing system, and how to maintain a chemical-free water treatment system. So highly recommend downloading that, learning up on it, because it will be the future of water treatment moving forward. Oh, and this is not the first time that VDI 2035 has been mentioned. Back in 2001 or maybe 2000, the CIBSE CP1 guide mentioned it as a viable alternative to chemical dosing. You can fill with demineralized water and treat it, and as followed by VDI 2035. It's also mentioned in CIBSE's Heat Network Design Guide as the VDI being better for large pipework systems with low and intermittent flow situations. So it's not the first time that VDI has been brought up, but now in 2026, that this TM20 guide is based on VDI 2035. So rather than using chemicals, chemical-free water treatment uses equipment that goes in the plant room. It's a 2-product solution, so you need 2 products on your system. You need the reaction tanks, so top right, you need the reaction tanks on your closed loop system that uses electrochemistry and sacrificial magnesium anodes to consume the dissolved oxygen below 0.1 milligrams per litre. And by consuming dissolved oxygen, it releases magnesium hydroxide, and that is how we regulate the pH to be between 8.2 and 10. So the reaction tank deals with 2 out of the 3 elements of corrosion, the causal elements of corrosion. And the second piece of equipment is our Profill, and that engineers the water via resin filtration, which demineralizes the raw water going into your heating and cooling system. It removes all your scaling minerals, such as salts, limes, and calciums. It removes your bacteria food, such as sulfate and nitrates and nitrites. It also removes the chlorides put in the water to make it safe for us to drink. So, but that attacks the passivation layer of metals, allowing for corrosion to take place. And effectively, what we're doing is we're demineralizing the water, but what we're achieving is very low or zero conductivity water going into your hydronic system. So these 2 pieces of kit will engineer your water so it's in a non-corrosive state. Now, the good thing about chemical-free water treatment is that it's completely scalable. Our smallest unit, our P1, can do 1,000 litres of LTHW. But for cooling systems, it can only do 650. And the reason behind that is the cooler the temperature of the water, the more dissolved oxygen it will have. So it needs more magnesium anodes. So that's why we have a lower limit on cooler temperature systems. The protector can work in multiple different pressure ratings, up to 16 bar, even higher if needed. And we have a maximum temperature of going up to 150 of these industrial units, which is what we use in our marine industry. But some of the astute will notice that our largest protector unit is a P1500, but this can only treat 1.5 million litres, which isn't enough to treat Lancaster unis, Lunzit. So that's not a problem, because you can multiply the number of units on a system to build up and surpass the system volume limit. So what we needed and what we chose for this system was 2 protector P900s, which both together will be able to treat 1.8 million litres of LTHW system. So very simple and easy to select our units for your system volumes. This is what it looks like. So it will be an installed side stream. These large units need its own pump. The flow rate through here will be 600 litres per minute, and it's designed to see, well, if it was 1 unit, it was designed to see the whole system volume every 24 hours. So this P900 will see 50% of the water every 24 hours, and the other unit will see the other 50%. So we're effectively treating all the water every day. So any oxygen ingress is being dealt with. To give a size aspect, it's about a 3,000 litre vessel size. Now the demineralizing unit, the Profill, comes in multiple sizes. So we got 2 litres for very small systems. What's going on? 2 litres for very small systems, 4 litres for 4 litres, 12.5, 25, 50, and the 50 can go on skids up to 2, 3, and 4 skids. So the site, we have 4 different sizing criteria, which are 3 of them are variables. So we need to figure out what your makeup water rate is going to be per annum. So a notional figure is 1% per annum. So 1% of 1,700 is 17,000 litres. So that's our starting point. Then we can decide whether to include the protector blowdowns, which is part of a maintenance because it is a side stream filter and it will collect dirt and debris. So to do biannual blowdowns, there's 2 of them, which is 3,000 litres, which amounts to 12,000 litres. So you add 12 to 17, gives you 29 metres cubed. Now the resin can be changed yearly or every other year or triennially, so every 3 years, because that's the maximum life it has sitting in water. So we times 29 by 3, and that gives you 87 cubic meters. That's your makeup water rate for your system. And that's where we figure out where we sit. So the Profil 3 skid can only treat 75,000 meters cubed, so it's too small. Whereas the skid 4 is over the 87 cubic meters. So that's how we chose the skid 4. But a fundamental thing about what the performance is of the unit is the local water hardness. So the local water hardness of Lancaster Uni is soft. So the performance of the resin goes much, much further. But the benefit of having a larger unit, specifically a Profil 54 skid, is that the flow rate is much higher than if you were to go for a smaller unit. This means you can use this unit to fill the system up with demineralized unit, but also in case there's an emergency, or in case there's a big leak and you need an emergency fill, you can still use this unit to get the system back up to pressure and full capacity. This is installed before the pressurization unit. And I'll just come on to the benefits very quickly, Simon, sorry. So environmental sustainability. So eliminates the use of harmful chemicals, reduces the environmental impact associated with chemicals, such as its production, the transportation, the dosing, and the draining of chemicals. It will align with your sustainability goals, your ESGs, and it mitigates risk of potentially releasing harmful substances to the environment. The health and safety, no handling of or storing of hazardous substances which pose risk to human health, reduces the potential for accidents, exposure, and associated health risks for workers and residents. No costs required, no regulations, so no risk of legal and financial penalties. Reduced maintenance costs, less maintenance compared to traditional dosing. Chemical-free water treatment is always on. It's passively reacting to system changes 24/7. Maximize equipment life by reducing corrosion and scaling. These systems can extend the lifespan of heat exchangers, pumps, valves, and other components, resulting in long-term cost saving and improved efficiency. Cleaner water without any additives will have better heat transfer by maintaining clean heat exchanger surfaces and reducing scaling. And compliance with regulations aligns with growing focus on environmental friendly and sustainable practices. Heat network operators can meet or exceed regulatory requirements related to water treatment and environmental standards. And that's me done. So thank you very much. Sorry I took too long. If you do not know about chemical-free water treatment, please get in touch and I will educate you.
No, thanks very much indeed, Peter. You're getting lots of thumbs up from the bottom of the screen. So that's
probably my colleagues. Yeah.
Oh, no worries. Applaud wherever it comes is appreciated. Okay, Tom, if you could drop Peter's slides, and if I could ask Richard, Steve, Terry, Peter, and Oisín to join the stage, we will have a quick Q&A session, if you don't mind. So, Peter, as you've just presented, there's a couple of questions that have come in at the top of the screen. One from Stephen Pete. Interesting presentation. Peter, does your system remove scaling? So does it remove existing scaling?
No, I don't think it does, but it will remove, so demineralized water is essentially a natural cleaning agent, but the scaling aspect of it, it doesn't remove it. It will remove existing corrosion, but not scaling.
Okay, no worries. And Richard, one of your fellow speakers, has asked a question: do you use biocides to protect against Pseudomonas in low temperature systems?
So no, like I said, we don't use chemicals whatsoever. We kill off bacteria by taking the pH above 8.2 and between 10. I know biocides, pseudomonas can live up to 9. We normally see our pH settle around 9.2 to 9.6, and that's outside the range of pseudomonas, which only survive up to 9 on the pH scale. Let's not forget, pseudomonas don't actually cause corrosion anyway, but they do cause biofilm. So,
right. Okay, that's very helpful. Thanks very much. There's another one from Andre Bullivin, but I think I'll gloss over that because I think there was more of a question of the audience about sediment in the system. So there was a question for Peter, which I see you've answered. I think that's fairly straightforward. The heat losses from the platinum to the boundary. Peter, did you want to talk any more about the one from Anupam about the compensation that you offer or you put into the system in Sheffield? That might be helpful just to explain a bit more.
Yeah, so I glazed over it quite quickly in the presentation, but we installed single plate HIUs across the development, which only gives a hydraulic break for the hot water system. So actually what happens there is the water that's being heated directly by the boilers in the energy center is then being transferred through directly into the radiators themselves. So the benefit of that is that compromise between resident comfort, particularly in winter, and then efficiency gains in summer. So we can vary the network flow temperature throughout the year based on how cold it is outside, in order to make sure that when it's really, really hot outside, we're not running the system at 80 degrees, but when it is really cold outside, we're able to run the system not 80 degrees, but actually 70 degrees in this case, in winter, to make sure that the radiators are hot enough to keep residents happy.
Okay, cool. Thanks very much indeed. Terry and Steve, although Richard responded to the question, which I think was incredibly helpful, I think that was actually directed at the two of you from LZ. Sorry for mispronouncing your surname. So it was, what controls or information are currently being communicated to ensure the commercial unit, which I think, if I recall correctly, was in your presentation, apologise if it wasn't, does not negatively impact the overall return temperatures on the network. Have I misspoken there, Steve or Terry, or is that a question you can respond to?
Yeah, no, I think I'll pick it up in the first instance. When we're looking at commercial HIUs, we're regarding them in the same way we regard Evinox HIUs. They just have a larger capability and a bigger performance because commercial space is more demanding. So we from a point of view of design and manufacture and maintenance of product, we don't regard a commercial HIUs in any different way to residential HIUs. And they're subject to the needs of, to be correctly set up in the first place, receive the appropriate inputs, in relation to flow rates and temperatures of water to enable and be maintained effectively to deliver the performance and the efficiency that they are capable of.
Okay, that's brilliant. Thanks very much. A couple more things before we draw it to a close. I was very intrigued, Richard, that you brought up there this BS out and one coming soon. Can I just ask you, what's the second, the BS2? What will that cover if the first one covers HIUs? Do you know?
I think it's more along installation processes, and it gets into some of the detail on like say the control side and stuff.
Okay, interesting. And just for other people in the room, I personally wasn't aware. I should have been aware, and my bad, that there was this BS8. I wonder whether any of the speakers are aware of it and how it interacts potentially with TS1, particularly that Fairheat produced. Clearly, it's a former specification for our sector. Would any of the speakers, are any of them aware of it? Would any of them like to comment on what's in the BS at all, or should we gloss over that question?
I mean, the -1 British standard is out, so that's the one that defines the different types of hot water, different types of HIUs classification into direct, indirect, the various storage types. So the -1 spec is already out, and that defines all the different HIU types in quite a detailed level. There's probably about 30, 40 different flavors of HIU.
Okay.
So that one's already out, and I think the idea is to align. It's aligning guidance is the key, isn't it? So that TS1 and British standards are all in alignment going forwards.
Yeah, absolutely. Peter, any thoughts? Or are you okay with that response from Richard?
Yeah, it's a good response. I think there's a number of documents, guidance documents, and British standards all doing similar things at the moment. You know, even in the water quality sector, there's another British standard soon to be published on what they're calling depleted water systems, chemical-free water systems. So there's lots of movement, hopefully all in the right direction, to align to TS1 and regulations.
Okay.
Yeah,
Cool.
that guidance from BISRIA is still guidance, not a standard. But yeah, hopefully they can combine the two, whether it's TM20 or BG89, and yeah, just start moving away from chemicals. It would benefit the environment for sure.
Okay. Question to Peter. There's one that's just come in before I ask one to Oisín and wrap it up to a close. There's one at the top of the screen. What is the impact on HIU and metering devices of water? Is there any recommendation and the thing you can do? Meter life can be guaranteed to 10 years. So I think the question is trying to get at the factors whether the whether there's anything you can do to extend HIU and meter life.
I mean, it's good maintenance and good maintenance practices. Good water quality is another very key thing that heat networks need to be keeping on top of to make sure that HIUs are operating for the expected life that manufacturers provide. You know, most manufacturers, whether it's boilers, HIUs, any piece of equipment, the first question they're going to ask when you know you ask for warranty or advice is, what's your water quality like? Because the moment that that goes, the likelihood is that you're not going to get your warranty. That's the same with HIUs.
Yeah.
So yeah, that would be my recommendation. It's I think a lot of this sort of stuff that we've seen very variable across the industry should start to become much more aligned when regulations and HNTAS come in, because there will be minimum standards put in place to make sure that maintenance is being done, so PPMs, water quality is being tracked and kept to a decent level, and hopefully that, you know, just through good practice will start extending the equipment's life expectancy. When it comes to metering devices, you know, my personal preference is to always have them as mains powered, because you're then not looking at, you know, battery lives dying, or, you know, batteries going after, let's say, 5 years, when you really want that metering data for the duration of the HIU that it's sat on. But yeah, that would be my advice when it comes to metering devices. I am very aware that there's also a metering and monitoring consultation due out anytime soon. So yeah, there'll probably be a little bit more information in there when that gets released.
Okay, and I think as we've got a fraction of time just to finish off, Anupam has asked Peter Linehan, have you got any comments, thoughts about water treatment and life of meters, and whether that, I suppose it's really chemicals versus chemical-free water treatment, whether either of them could particularly extend the meter life at all, whether you've got any views? You don't have to have a view.
Honestly, I haven't seen any specs for meters about water quality. but I have seen what Grundfos say about additives in the water. It says it could cause malfunctioning of their pump. So I don't know if that's similar of meters, whether it affects the measuring rate of meters, but cleaner water can only be better for all components: meters, valves, plated exchangers, and pumps. What I would say and highlight here is what I'm seeing, especially with the introduction of air source heat pumps, is that each one has individual water parameters that you have to meet to achieve their warranty. I would say that VDI is more of a holistic approach, and it's engineering the water to a non-corrosive state rather than a particular component's water parameters. The good thing is about these new heat pumps coming in is that they are specifying very low or low conductivity, normally below 500 microsiemens. So that steers everyone towards chemical free, because as soon as you start dosing with chemicals, you're going to take the conductivity of the water to near 2000. So, which is why we're seeing an uptick in business and systems that we're treating because of these, because of the decarbonisation schemes.
Okay, brilliant. Thanks very much. Final question, Oisín. To try and answer, possibly not for the River Thames, but for other things you've been involved with in terms of sort of feasibility studies, have you come across any issues in water source heat pumps on rivers in terms of sediment filtration, stable temperatures, things like that in any of the systems that you've modelled? If you haven't, no worries, but I just thought we'd ask that question to yourself, Oisín, whether you've...
No, I don't think we've come across actual... I'm trying to think across the different projects that we did the modelling on. I don't think we ever got to the level where we could look at the sediment, which is why the next steps were always put something in place to monitor water quality, like your dissolved solids, your turbidity across like a long period of time, because obviously that will impact on the installation or the likelihood of something being viable in that place. Like any community group can look at a river or a water resource, whatever it be, a burn or a lake, and say, yep, we'll do water source heat. But in situ monitoring is really, really important to get that viable, and then engagement with local authorities and permitting agencies as well, because they'll obviously have a massive say on what is or isn't viable, and they'll have their own rules and hoops you'll have to jump through.
Okay, no, that's brilliant. No, thanks very much indeed. Well, we've reached the end, just about on time as well. So I'd just like to thank all the speakers. There's lots of nice words of thanks in the chat. Very helpful field presentations, lots of information. So thanks to Peter, Richard, Terry, Oisín, and Steve. And we wish you all a great day, and we'll draw this webinar to a close. Thanks very much indeed.
Thank you.